What is the law of sines? At the end of this lesson, you will be able to derive the law of sines. Before we begin, make sure to download and print out the law of sines handout, which can be found at that web address. It'll also be available on the web page where this video will be posted. If you cannot print it out, then you can simply copy the diagram and follow the directions. So let's begin. Right triangle trigonometry can be used to solve problems involving right triangles. So right triangles, just to remind you, are triangles that have one right angle. And we can use things like sine, cosine, and tangent to find missing sides and missing angles. However, many interesting problems involve non-right triangles, such as obtuse triangles or acute triangles that don't have right angles. In this lesson, you will use right triangle trigonometry to develop the law of sines. The law of sines is important because it can be used to solve problems involving non-right triangles as well as right triangles. Make sure that you did the right triangle trigonometry review before you did this lesson. Steps 1 and 2. Consider the oblique triangle ABC shown to the right. Okay. Step 1. Sketch an altitude from vertex B. So vertex B is this point right here. An altitude is a perpendicular line that goes from that vertex and makes a right angle to the opposite side. So to do this, you are going to need a ruler or some other kind of straight edge. And this is what you're going to make. A line connecting B to the opposite side, but you're looking to make sure that you have a right angle at the bottom. Great. Now let's label that altitude K. All right, we're ready to move on. The altitude creates two right triangles inside of triangle ABC. Notice that that angle A is contained in one of the right triangles. That would be this triangle on the left. And angle C is contained in the other triangle. This is the triangle on the right. Using right triangle trigonometry, write two equations involving sine of A and one involving sine of C. Recall that the sine is the opposite side over the hypotenuse. All right, go ahead and give it a try. So let's check your answer for the first one. Did you get sine of A is equal to K over C? K would be the opposite side from angle A, and C is the hypotenuse. Go ahead and try the sine of C. Did you get that the sine of C is equal to K over A? That's because across opposite side from angle C is the K, the altitude, and the hypotenuse of this triangle would be side A. All right, let's move on to the next step. So notice that each of the equations in question 3 involves a K. Think about why does this happen? So then let's solve each equation for K. So for the first one, we had the sine of A is equal to K over C. So we're trying to get K alone. So we need to get rid of the dividing by C. So let's multiply both sides by C. So then the C's would cancel. And we would get C times the sine of A is equal to K. Go ahead and do the same thing for the other equation with the sine of C. Did you get that K is equal to A times the sine of C? Great. So now let's move on to step 5. Since both equations in question 4 are equal to K, they can be set equal to each other. Why is this possible? So let's set the equations equal to each other to form a new equation. Did you get C times the sine of A is equal to A times the sine of C? Good. So since they were both equal to K, that means that these two expressions are equal to each other. Let's move on to step 6. Notice the equation in question 5 no longer involves a K. Why do you think that is? Write an equation equivalent to the equation in question 5, regrouping A with sine of A and C with sine of C. So we had C times the sine of A is equal to A times the sine of C. What they're asking you to do is get the side A and the angle A onto the same side, and the side C and the angle C onto the same side. Give it a try. So in order to move the side C from the left side to over to the right side where the angle C is, I divided both sides by C so that the C would cancel here. Now remember that this C and this C cannot cancel. This is the lowercase c that represents the side. This is the capital C that represents an angle. Now we still need to get this A to the other side, so we need to divide both sides by A. Notice here that I instead decided to multiply by 1 over A. This is equivalent to dividing by A, but it's neater and easier to work with when you already have a denominator that we do with the C. So the A's will now cancel out, and the little a, the side A, is now on the other side. So we get the sine of angle A over side A is equal to the sine of angle C over side C. So now we're going to move on to the back. And the back steps are very similar to the front, but we're looking at the whole picture from a different perspective. So again, we're going to consider this triangle, and we're going to sketch an altitude, but this time the altitude is going to be from vertex C, which is this angle right here. So we're going to get our straight edge in our ruler, and we're going to label it. Go ahead and give this one a try on your own. Okay, so here's where it should be, going from vertex C to the opposite side so that it makes a right angle. Perfect. So now we're going to do all of the same steps, but we're going to be doing it using this altitude. And so this altitude breaks the triangle into two different right triangles, one down at the bottom and one more on the top. Step 9. The altitude creates two right triangles, like we just mentioned, and angle A is contained in one of the right triangles, and angle B is contained in the other. Using right triangle trigonometry, write two equations, one involving sine of A and one involving the sine of B. This is just like what we did in the earlier step, so give it a try. Did you get that the sine of angle A is equal to K over B, and that the sine of angle B is equal to K over A? So angle A, the sine is opposite, which is K, over the hypotenuse. B is now our hypotenuse of this triangle. And for the other angle, angle B, opposite is also K, and the hypotenuse this time is A. So notice once again that we get two equations that involve K. Let's solve each equation for K, just like we did before. Then we're going to go ahead and do step 11 as well. Since both equations are going to be equal to K, we can set them equal to each other. So these are the same two steps we did before. Go ahead and give them a try. So for step 10, just like we did before, we need to multiply both sides by the variable in the denominators that they will cancel, because we're trying to get K alone. So if we multiply both sides by B, the B's will cancel, and we get B times the sine of A is equal to K. Then, similarly, here we need to multiply both sides by an A so that the A's will cancel, and we get A times the sine of B is equal to K. Did you get it right? If not, look at what you did, see if you can analyze what you did wrong. All right? Then try step 11. So setting them equal to each other, we get B times the sine of A is equal to A times the sine of B. So let's go ahead and go on to step 12, where we're going to use that equation, and we're going to rewrite it by regrouping side A with angle A, just like we did before, and side B with angle B. So this is just like we did with the other triangle on the other side of the paper. Go ahead and give it a try. So this time I did a little bit differently. Instead of dividing both sides by b and then dividing both sides by a, I divided both sides by b and a at the same time. This makes the process a little bit more efficient. So when I do that, here the b's would cancel, leaving us with only an a in the denominator, and here the a's would cancel, leaving us with only a b in denominator. So we get what we want. The sine of angle A over A is equal to the sine of angle B over B. So finally, we're going to put this all together. We're almost there. We're going to use the equations that we found in question 6 and question 12 to write a third equation that not only involves two angles and two sides at the same time, but we want to look at all of them at the same time. So A, B, and C. So let's remember what we got from question 6. From question 6, we got, remember we were using angle A and angle C. We got the sine of angle A over A is equal to the sine of C over C. What we just got in question 12 was very similar. We got the sine of angle A over A is equal to the sine of angle B over B. Notice that both of these equations involve this expression right here. And so by the transitive property, we can pretty much say that all three of these things are equal. So putting it all together, we get the sine of angle A over A equals the sine of angle B over B equals the sine of angle C over C. And remember where all these things came from. We had this triangle with angle A here, and the side opposite from angle A was also A. That's the lowercase a. Then we had B, and opposite of that we had side B, and angle C finally, and opposite of that side C. So pretty much we have the sine of an angle divided by the side opposite of it is equal to the other angles. Divide the sine of the other angles divided by the sides opposite. And there we have the law of sines. In the next video, we're going to look at how do we use this.